I am Gayatri, working as assistant professor in EC department at SNS College of Technology. Today I am going to discuss about the topic Kirchhoff's law, which was studied by the first year students in the subject Fundamentals of Electrical and Electronics Engineering. Before going to the discussion about the topic, let's have some recall about the previous topic what we have discussed, which is DC circuits, which is having a conductor, resistor, inductor, and capacitor. The conductor nothing but it allows the current to passes through the circuit, and resistor which is opposite to that of conductor which oppose the current flow in the circuit. The energy storage device which is basically inductor and capacitor. The inductor which stores energy in the magnetic field, and capacitor which stores the energy in the electric field. The topic for the discussion today, we am going to discuss about the Kirchhoff's law, which is classified into two types, which is Kirchhoff's current law and Kirchhoff's voltage law, and applications of circuit analysis where we are using that, and also the real world examples and advanced concepts in the Kirchhoff's law. And let's expose some the Kirchhoff's law. The Kirchhoff's law, which is the introduction part of the electrical circuits. Before going to the Kirchhoff's law, we have to know the basic component, which is resistor, voltage sources, and current. And the history of Kirchhoff's law, which is Goods of Kirchhoff, which was in 1845. It was introduced, and it is based upon the conservation of charges and energy. And basically the Kirchhoff's law is very important in the closed loop circuit, as well as is to analyze and to solve the complex circuits by using the Ohm's law derivations. And coming to the types of Kirchhoff's law, which is the first one will be the Kirchhoff's current law. It is nothing but, for example, when we are having a node A, and the current will be flowing through that particular node, and the statement for the Kirchhoff's law is that the sum of the entering current will be equal to sum of the leaving current. Based upon the conservation of energy, we can say from this figure, the current I1, I2 and I6 are entering into the node A, whereas the current I3, I4 and I5 which is leaving the node. So from the equation we can narrate that I1 plus I2 plus I6 which is equal to I3 plus I4 plus I5. Then coming to the Kirchhoff's voltage law, which is narrated with the help of only closed loop. The sum of the potential drop will be equal to sum of the potential rise. And it is also based upon the conservation of energy. From taking this figure into consideration, where the potential rise of this circuit diagram is 45 volt, and the potential drop across the resistor R1 and R2 and R3 can be calculated by using the Ohm's law. Then V, which is equal to V1 plus V2 plus V3. As well as in a second circuit also, the voltage source of the circuit is A, B, C, D and F, which is equal to 0. Then coming to the loop rule, the direction of voltage traveling will be taken as when the resistance is there, the current will be flowing there, and voltage drop will be there in the node VB, VA and VB, where the potential drop is VB minus VA, which is equal to minus of IR. When the direction of travel is in from A to B and direction of travel is from opposite to that, then the potential difference which is equal to VA minus VB, which is equal to IR. Then when the potential drop is there and direction of travel which is same, then VB minus VA which is equal to plus B, and del V which is equal to VA minus VB which is equal to minus B. Then coming to Kirchhoff's empathy part, which is what are the system that power device like phones or light, so that the Kirchhoff's law rule can be applied in the flow of electricity, and also in the pipeline connections, the Kirchhoff's law can be applied. Imagine when we are planning a family budget, the money should be equally splitted or unequally splitted. So here in the part we can also apply KVL and KCL. Helps to design the devices. We can when the amount is equally divided. Then coming to the defined part, the Kirchhoff's law are the fundamental basic principle that is used in a complex circuits as well as in simple circuits to find out the current flowing through the resistor as well as voltage drop across the resistor. And the applications of circuit analysis is nothing but it is used in the power system mesh nodal analysis as well as to find the resistor in parallel, resistor in circuit also be this the KVL law and KCL law can be used. But the limitation of this law is cannot be used for high frequency or non-linear circuits. Advanced concept in this applying KVL law is that the superposition theorem integration and software simulation can be applied for this KVL and KCL law. And coming to the summary part of this topic, KVL, Kirchhoff's rule, it is classified into two types, which is KVL and KCL. The KVL is nothing but sum of entering current will be equal to sum of leaving current. And KVL, it is nothing but the potential drop, sum of potential drop will be equal to sum of potential rise. Okay, activity which is based on 5 pillar and the key focus is listed below. And quiz questions, the KCL will be based on the fact that there cannot be accumulation of charges at particular node. The algebraic sum of voltage around the closed loop in a network, it always should be equal to 0 and not 1 or infinity. Okay, these are the references I have taken for this topic. Thank you.